Technology advances in additive manufacturing and unmanned aerial vehicles have merged paths as Army researchers explore a new concept. American warfighters of the future may be able to custom build drones for specific missions using an App Store-like interface on a tablet or computer, and 3D printers would go to work, creating easy-to-assemble parts in less than 24 hours. This was the concept thought up by aerospace engineers at the U.S. Army Research Laboratory at Aberdeen Proving Ground, Maryland, just a couple of years ago. Now, the idea has taken flight.
Several years ago, when we were collaborating with our academic partner, Georgia Tech, we had this project where we were focusing on design engineering of small unmanned aircraft systems. So in this case, it was quadcopters and also fixed-wing UAS or UAVs, drones. And what we realized is that the task that we were working toward was a software tool or a design-on-demand capability. And in order to validate what we were doing, we realized we need to do some prototyping.
The team's efforts landed them with an opportunity to showcase their concept to the U.S. Army Training and Doctrine Command at Fort Benning, Georgia. In December 2016, the team traveled to the Army Expeditionary Warrior Experiment, or AEWE.
They want to get technology or upcoming technology into the hands of soldiers, let these soldiers try out the technology and give you honest feedback. As researchers, what it helps you do is it helps you guide your research thinking to actually fulfilling capability needs rather than just pursuing interesting ideas. What we learned was that soldiers saw a lot of benefit and merit in having a small 3D printed UAS at their disposal. So we came home from AEWE with the answers that we were seeking, the potential benefits and merits of these technologies.
The researchers felt the combination of 3D printing and UAVs was a natural technology solution.
From the beginning, it's been really important to have a strong belief that this is the right way to do things, because we're up against a lot of opposition from the sort of status quo in how a small UAS or unmanned aerial system is acquired and used. And while it makes sense in the context of a large vehicle to have a big drawn-out acquisition cycle where you collect requirements and build a vehicle that meets as many of those requirements as possible, in our case, it's necessary to totally rethink that entire process. And so it was extremely important for us to be championing that idea from the beginning to really give it some legs and to prove to people that this was the way to go.
Additive manufacturing, or 3D printing, is maturing as a viable way for creating mission-essential items at the point of need, providing soldiers with a technology solution. However, it is not without its challenges.
As a researcher, I'd like to improve the speed of the print or the strength of the printed part itself, both of which are kind of downfalls of additive manufacturing right now. So taking 3 or 4 hours to print a small part, we'd hope to reduce that by at least half and have it be done in say an hour, and then having that part be more towards what an industry, say an injection molded part would be. They don't quite have that same strength as injection molding still. So being able to have it compete with an injection molded part would be great.
Army research into 3D printed drones took an unexpected turn in late 2016, as Marine Corps Commandant General Robert Neller sought ways to increase UAVs down to the squad level.
We do work for the Marine Corps whenever we can. It's that part of the research that allows us to be land force scientists and engineers and to deliver solutions not only for soldiers but for Marines wherever we can too.
So we saw this as a way to merge what we were doing into what another service's future vision was. And so we embarked on this project. So we wrote a proposal. It was accepted by the Marine Corps, and what we were looking at is we were proposing that we could do on-demand design, right? So you tell us the type of mission that you want to perform, and we'll create software that actually designs that vehicle on demand. And the Marine Corps said, slow down, that's a great idea, but first what we're looking for is a catalog of drones.
A software catalog would provide the end user with a way to choose aircraft capabilities tailored for a specific mission.
My role was to develop the small UAS catalog that soldiers and Marines would use to select the vehicle that they want to perform their mission with. So the idea was that we wanted to gather a large group of UAS vehicles and put them all in one place, and then have it in a catalog format, for instance, like something like Amazon or something you'd find online.
The Army researchers traveled to Camp Lejeune, North Carolina to meet with Marines for a build-a-thon. They wanted to see how long it would take Marines to assemble the 3D printed parts into an airworthy drone.
That's kind of a unique perspective for them, since typically they're just given things and told to use them without actually being in the loop on the development of those items. So by kind of inserting the Marines into our development cycle, we were able to really get some more detailed feedback on what their needs were, and now we can take that feedback and really target it and make sure our vehicles are exactly matched to what they want.
I definitely didn't know that you had this capability with the 3D printing. I see it's got a great start to it. Who knows, here in 5 or 10 years where it'll be at.
In September 2017, the researchers returned to Camp Lejeune to gather more feedback and let the Marines fly some prototype 3D printed drones.
I think it's going to help a lot with keeping things on a cheaper scale, as well as helping provide that watchdog for the lower infantry guys going in as they're getting into a area that things may seem heavy. Instead of really putting themselves at a higher risk, you can put in a drone that could be anywhere from, I don't know, $200 to $1,000. That's much cheaper than a Marine's life.
One of the major advantages of additive manufacturing is customization. So being able to provide the warfighter with the right tools at the right time. Many different warfighters have many different jobs, their tools are different, and we might not be able to stock and store all of those different types of tools. So having an additive manufacturing capability near the point of need or near in-field operations would allow for soldiers to be able to manufacture those tools whenever they need them.
I think we have come a long way, but I would give credit to not only the team, but especially the feedback that we were getting from these soldiers and the Marine Corps. When we were showing them the technology, we would ask questions about, if you had this capability to design a small aerial system overnight, basically, what kind of benefit would that provide you through an additive manufacturing focus and a small UAS focus?
Armed with valuable feedback, the research team hopes to streamline the process into an integrated solution to provide warfighters, both soldiers and Marines, with easy options for delivering situational awareness.
Cover me while I move.
It's very important to know there's a corner right there. Is there going to be someone on the other side? Instead of just sending in one of the new guys to go and clear that out or clear out that room, just throwing something in there. Because you obviously hear so many stories of Marines dying within a building because of an insurgent within that building.
We have interacted with Marines that have never touched an unmanned system before to Marines that are experts in unmanned aerial flight. And across the board, they all seem to be very interested in the topic of being able to manufacture a tool that they could use that was mission specific and have it turn around so quickly. In fact, they expected the turnaround to be days or weeks, when in fact we showed them that the turnaround time can be anywhere from minutes to hours.
I think the next stage is going to be to try to increase the sophistication of not only the vehicles, but the underlying processes that are used to realize the vehicles. So that would include the 3D printing. We have ideas to basically optimize the entire structure of the vehicle using something called topology optimization. Basically, that ends up giving you a design that looks very organic and biological in nature, sort of like a spider web or a complicated truss. And by doing that, you get a very lightweight but still very stiff structure, and so you can save more weight. And then also we'll be working on improving the software side of things as well.
Based on the rounds and rounds of feedback we've gone to the warfighter, to soldiers, to Marines, back and forth getting feedback, incorporating the feedback into the catalog itself, incorporating the feedback into our design methodologies. I think that we stand a pretty good chance of capturing all the needs and requirements that the warfighter has.
So the catalog that's used to select vehicles currently will be expanded, and then we'll be able to actually customize vehicles instead of just select them. And then finally, we'll try to increase the sophistication of just the vehicle itself and how it functions.
I think a lot of folks are interested in additive manufacturing because we've seen on sci-fi shows throughout, growing up, throughout our life, just walking up to a user interface and saying, cheeseburger, and there's my cheeseburger. And I think that as additive manufacturing continues to grow and the technologies continue to evolve, that we're going to get to a point eventually where we will be making things in a similar fashion, where you will walk up to a user interface and say, unmanned aerial system, and it will make it for you.
So advantages include speed. Another advantage is cost. There's definitely a cost benefit because the systems that we're envisioning are modular. From a user that's wearing a uniform that has to perform a mission, they have to be able to trust the system to do what it's intended to do, and they have to put the focus on themselves and their mission, not on taking good care of that system, because the system needs to be durable, the system needs to be repairable, the system needs to be potentially expendable.
There's a lot of things that have to come together at once. A robotics engineer could not just make a drone or make a machine that would make a drone, right? You also need to understand materials. So you have robotics and mechatronics, and you have manufacturing science and material science, and all of those things have to work together before you can figure out how to really create a three-dimensional object in three-dimensional space and manufacture that object. How we fit in, how ARL fits into the industrial base, the manufacturing industrial base in this area, is that it's our job to do the research in manufacturing science and material science for the future of the Army. We will boost the manufacturing industrial base because there are not a lot of research facilities like ours that can spend the time or money to develop these new types of technologies.
What we do know is that the battle space of the future is going to be evolving and extremely complex. That's why we need to invest in numerous technology streams, things like additive manufacturing with materials, artificial intelligence and machine learning, unmanned systems technologies. These will enable us to bring together the capabilities that will allow the future soldiers and Marines the decisive edge that they need in the battlefield. And the Army Research Laboratory will continue to invest in these types of technologies to give our soldiers of the future the best possible outcome in any environment.
In the future, 3D printed aircraft, custom designed and manufactured at the point of need, will meet warfighter expectations with lower noise, a longer standoff distance, heavier payloads, and better agility. As Army researchers continue to discover, innovate, and transition technology solutions to deliver the decisive edge on the battlefields of tomorrow.